Hey there, geometry folks. I'm going to try something a little bit new this time with the test review key. Instead of doing one big long, 20 or 30-minute video, I'm going to try to do it page by page. So I'm going to do a smaller video for page 1, page 2, page 3, page 4, and the page for constructions, just to see if it makes the organization just a little bit better. So without further ado, let's jump right in here and take a look at page 1. This will be questions 1 through 6. And it says, number 1, we have this picture here, and hopefully you can see the difference between the vertical plane and the horizontal plane. And it wants to name the line segment that's created by the intersecting plane. So if you look and see where those two planes intersect, I'll highlight it here in red. Right there. From that dot that we call B, or point B, all the way over to point A, it is a segment, so I have to name it two different ways. I can call it AB, or I can call it BA if I want. Either one of those two would be just fine. Number 2 says, name one of the planes shown in two different ways. So one plane. So I don't know. I'll do this plane. Right there. Highlighted the one in green. If that's the plane that I want to name, I can name it by plane. That kind of cursive looking letter that you can tell it's not a point. It's in the upper right hand corner. There's no dot with it. So that's not a point, but we can call that plane P. The other way I can name this is any three non-collinear points. I mean, they cannot be in the same straight line. So plane, and I need three of them. So I don't know. I'll go C, A, and E. So C, A, E. Remember that they just have to make sure that they are not all in the same straight line. Okay. The next one wants to know our points at G and F. So let's see, here's G and F. Are they coplanar? Are they in the same plane? Yes, they are. They are both in plane R. If you want to know which plane that is plane R. And the last one here, number 4, says, are C and H collinear? Now, the answer is no, because I do not see that they are connected in any way. But understand this. In reality, if we're talking about in three-dimensional space, really any 2 points in three-dimensional space, there is some line that would connect those two. But by looking at the picture, are they collinear? No, they are not shown to be on the same straight line. So I would say no, they are not collinear. Okay, let's jump down here to number 5. Number 5 wants us to use the diagram to the right to answer the following questions. Name the vertex of angle DCG. So I'm going to first highlight it. D to C to G. So that's the angle that I'm talking about there, DCG. And the vertex is the point where the two rays come together and meet, and they meet at point C. Some of you are saying, well, isn't the vertex always the middle letter? Yes, that's also true. Right? That middle letter is always going to be the vertex. Part B says name the sides of angle EFB. So again, EFB. There's my angle. See it highlighted green now. It wants to know the sides. Sides are rays. So I'm going to start at the vertex, and I have FE. That is a ray. And the other one would be FB. And that is also a ray. So notice that I put the little ray symbol above them to show that they are rays, in fact. Okay. And the third one, 5C, says write another name for angle ABF. So ABF, right there. And if I have to name that another way, I would like to use a number, but there is no number in there at B. I would like to just call it angle B, but I can't do that either because there are actually 4 angles showing up right around there. So I can just switch the A and the F actually and call this angle FBA. You do have to make sure that B is still in the middle, however. B must stay in the middle. All right, number 6. Number 6 says in the figure to the right, segment MH bisects segment TA. So that means TA has been bisected. It means cut in half. And you'll see on the picture that TR, so this distance here from T to R, and the distance from R to A, they have the 2 little hash marks. I'll circle them right here. These 2 little hash marks. That tells us that those 2 segments are equal, that they are congruent, they are equal in length. Okay, so we have 2 congruent segments. So it says find TR, this is what I'm looking for. If TR is 2x plus 3, and AR over here is x plus 7. Now I just said the word bisect means to cut into 2 equal pieces. So I'll just set the 2 pieces equal, 2x plus 3 and x plus 7. Those 2 things have to be equal to one another. So I'll subtract 3 on both sides. So 2x equals x plus 4. Subtract x on both sides, and x equals 4. Now, the problem does not ask me to find x. It doesn't say find x. It wants us to find segment TR, so the distance from T to R. Well, we know that T to R, says it right here, is 2x plus 3. Well, if x is 4, let's do substitution. All right, one of the things as we start talking about proofs, substitution or transitive, this happens to be substitution. If x equals 4, 2, I'll substitute in a 4 plus 3. Now 2 times 4 is 8, plus 3 is 11. And this is a distance. I don't know what it's measured in, so I'll just call it units. It is 11 units long. That takes care of the first page, page 1. The next video will have page 2. Thanks.